In this video, we're going to talk about how to graph using our graphing calculators, as well as where do we get that important information. So we have the equation y equals x squared minus 2x. So the first button that you want to push on your graphing calculator is that y equals button right there. In the y equals menu, you want to make sure that you graph that equation, you enter that equation exactly as it's written. You also do want to make sure that up here, sometimes those plots up there, they can be turned on by accident. So you want to make sure that none of those plot 1, plot 2, or plot 3s have a black box around them. If you do notice that there is a black box around them, use your arrow keys to go highlight over them, press enter when you are blinking on top of them. You need to make sure that those are off, otherwise you will not be able to graph. Once you have that equation entered into your y equals screen, go ahead and press your graph button, and you will see that this graph pops up. What we want to know is we want to know where the vertex is of this graph. Well, your vertex is going to be about right there. So when we look for our vertex, we want to push our second button, then our trace button to go into our calc menu. And if we look at the graph, we notice that that vertex is a minimum. So we are going to find your minimum in there. So click on option number 3. When you are back at the graph, your calculator is going to ask you a series of questions. They're going to say your left boundary and your right boundary. Because your vertex that we're finding is about right there, you need to move your blinky bug guy somewhere on the left of that vertex, and then move your blinky bug guy to the right of that vertex. When you are on the left side, you need to press enter, and then it will change the question to say, what is your right side? Then you move your bug to the right, press enter, and then enter one more time. Your calculator will then give you the XY coordinates of your vertex. After doing so, your XY coordinates of your vertex are going to be 1, -1. So let's go ahead and plot 1, -1 on our graph. The axis of symmetry, remember, is that symmetrical x equals equation that is a vertical line that goes through your vertex. So it is going to be x equals 1 because these numbers will be exactly the same considering your axis of symmetry goes through your vertex. We can identify that this graph does open up, and therefore your vertex was a minimum. So now let's go ahead and let's look at some of our other important information. We need to know our domain, our range, our x-intercepts, y-intercepts. Y-intercept, you know, is the place that it crosses the y-axis, so your x is equal to 0. Your easiest place for you to figure out where that is it's going to be the location that your graph crosses the y-axis. Easy way to find this is go ahead and hit your second button, then your table. Go into your table, find that place where x equals 0, and you will notice that your y-intercept is the coordinate 0, 0. Your x-intercepts are the places that your graph crosses the x-axis, so your y value is 0. And if we look back at our graph, it happens to be also here, and then there's another one right there. So in order for us to let our calculator do a lot of this work for us, we want to use your 0 feature. When you use your 0 feature, you need to make sure that you are going on the left side of the 0 and the right side of the 0. You also can go to your table, and you know that if it's an intercept, your y value is equal to 0. In this particular graph, looking at your table, you see in your table that you have a y value of 0 when x is 0, and also a y value of 0 when x is 2. So those would be my intercepts. And we can see them where I have those arrows. It does go through the origin, and it does go through right there at 2, 0. But if they're not easy to recognize, that would be a great place where you use your 0 feature. Again, left side, right side. If this is the 0 that we are investigating right here, this bug would be on the left, this bug would be on the right. This would be right, this would be left. If you have a parabola that might open down, and you are investigating that 0 right there, this bug would be on your left, this bug would be on your right. So you have to make sure that you know your lefts and your rights if you are indeed using that 0 feature. So let's look at some of our other points that they want us to plot. They wanted us to plot the y-intercept, which was my origin. So I'm going to plot a point there. We had an x-intercept at 2, 0, so I'm going to plot a point right there. And if I want to just make sure I know exactly what this graph looks like, I'm going to go to my table, pick another couple spots. One of them was 3, 3, and another one was -1, 3. There is symmetry in this parabola. And then we can get a really good picture of what our parabola looks like. Domain are your x's. Anytime that you're looking at a parabola that opens up or a parabola that opens down, because it will continue to get wider forever, your domain will always be -infinity to +infinity. Range is your y values. What y values are you using? We describe both domain and range going from negative to a positive number. So we say, how low does this graph go on the y? It goes from -1 inclusive, so we use a bracket, through how high? Well, it continues to go up forever, so through as high as +infinity. And this is all the important information that we would want to graph. If you do want to see what your axis of symmetry would look like, it would be a dashed vertical line that goes through your vertex. That is the line that if you folded this graph on top of, or along that line, the left side and the right side would be on top of each other. That is why it is called your symmetrical line.